web seminar in a series of 4 web seminars organized under the umbrella of the project mySMARTLife. My name is Mathieu Grosjean, and I will introduce and moderate this web seminar. I work for a German organization called Steinbach Europazentrum, which provides consultancy services in the field of innovation management. mySMARTLife is a smart city project which is financed by the European Commission under the umbrella of its Horizon 2020 Research and Innovation Funding Program. Our role within the project is to lead dissemination and communication activities, but it is also to manage its IP assets and to support the market deployment of a set of solutions validated and demonstrated in the cities of Nantes, Hamburg, and Helsinki. If you are interested in the solutions developed within mySMARTLife, please don't hesitate to get in touch with us. We will be glad to advise you. So, on the slide, you can see now, this is how the web seminar is structured. In what follows, I will briefly introduce the main goals to be achieved by the project mySMARTLife and how they relate to the exploitable results presented here. Hannu Pikarainen is head of capabilities for new businesses at HELEN Limited, the energy company owned by the city of Helsinki. He will present the heat demand response service developed in the Lighthouse City of Helsinki. It is a solution enabling to shave energy peaks. Then Louis-Frédéric Robin is Group Director Cities and Infrastructure for Public Lighting and Safety Solutions at ENGIE, a French multinational energy company. He will introduce us the public lighting project implemented in the Lighthouse City of Nantes. Afterwards, Doris Wilmer, who is project manager for Energienetz Hamburg, which is bringing the energy transition with the help of the citizens of Hamburg. She will share their secret on how to make citizens the main actors of the energy transition using the electric power tenant supplies solution. Finally, Ingo Fries, who is working in T-Labs, Telekom Innovation Laboratories, will describe the open urban platform developed with the Lighthouse City of Hamburg to increase the openness and flexibility of its existing platform. Finally, we will close this web seminar with a session of questions and answers where all attendees are encouraged to interact with our guest speakers. We will collect your questions during the web seminar and address them during this last period. This will be the right moment for you to ask, to share your views, and to start exploring cooperation opportunities with our speakers. So, let us now shortly focus on the project mySMARTLife itself and its exploitable results. mySMARTLife started in December 2016 and brought together 27 project partners from 6 different countries with the aim to achieve essentially one central goal, collaborating to make sustainable cities with smart people and a smart economy a reality. The activities related to the refurbishment of buildings, usage of renewable energies, clean transport and supporting ICT solutions and implemented during this project are making the 3 lighthouse cities of Nantes, Hamburg and Helsinki more environmentally friendly by reducing the CO2 emissions of cities and increasing the use of renewable energy sources. The 3 follower cities, Bugdoș, Rijeka and Palencia, learned from these experiences and already adapted and adopted some solutions covering their needs. Ultimately, An integrated planning process where citizens are actively involved in the decision-making links the actions in different fields. For example, mobility, sustainable energy, ICT. Following a structured city business model leads to an integrated urban transformation strategy, which can be easily transferred to other cities. Our guest speakers will develop these ideas further. So at this point, the only thing left to mention is that your microphones have been muted to prevent any interruptions while the speakers carry out their presentations. Should you have comments or questions for our speakers, please don't hesitate to send them using the chat box. We will collect them and ask them aloud to our speakers at the end of this web seminar. Having introduced you to the project and to its objectives, the next presentation will be on charge of Hannu Pikarainen, who will present the heat demand response service. Hannu, the floor is yours.
Thank you, Matthew. All right, let's start with a brief background on HELEN. HELEN is about 1,000 people company, and we make a net sales around 900 million euros annually. And for this topic, the 1,300 kilometer district heating network is the basic resource. We also, in addition to district heating, we offer district cooling, electricity and services for various types of micro generation of energy like solar panels and so on. And then we are also involved in electric traffic like EV cars and so on. And our target is to be carbon neutral by 2035. Next slide, please.
Can you share your camera, please?
Of course. We already circulate heat quite heavily in Helsinki. We produce heat in multi-fuel power plants, and also we collect heat from data centers and wastewater. And then we also have quite a number of thermal storages where we can store heat. And we recently opened a new cavern heat storage facility, and filling that with water took already several months. So there's quite a lot of capacity. But now we also in this project, we wanted to study how we could use buildings, the mass of the buildings, as energy storage. Next slide, please. So what do we mean by heat demand response in this case? For instance, in apartment buildings, when people take a shower in the morning, there is a certain peak in heat demand. And if we could move that peak and flatten the consumption of heat in the network, we could end up to lower energy costs because we can optimize the use of fuels. And this also means that we could end up to lower emissions. So that's the kind of the basic idea with heat demand response in this case. Next slide, please. And what did we do in this project? We did studies and pilots. We calculate business scenarios for heat demand response, and then we did a residential building pilot and office building pilot, and there we had SALUSFIN and FOURDEG as our partners. Next slide, please. First of all, about the business scenarios. The idea was to find out what kind of capacity there is and what kind of capacity we do need to optimize the heat heat production and consumption with these buildings. And then also to find out the costs, implementation issues and profitability. Next slide, please. So I'm presenting here the business as usual scenario as one of the scenarios, and there we did include 550 residential apartment buildings and 50 kind of office building or that type of premises into the calculations, and that amount of building is around 10% of high-rise buildings in Helsinki. And from that amount of buildings, if the power can be used optimally, we can get about 100 megawatts power. And the calculation shows that it is about 10 years payback time, so the solution would end up to savings in energy procurement and also in the production of heat. And currently we have a piloting capability, but there is no commercial use. Next slide, please. And in the residential and office building pilots, we developed an interface to our production planning and optimization system, and from that interface the smart heating management system providers can get the heating upload and unload requests for buildings. So basically they are based on the demand of optimizing the production planning and the usage of demand in Helsinki. The peaks then would be kind of managed in the buildings. And in the apartment buildings there were smart thermostats, and also in the office building smart thermostats that were then controlled. And the key item here, in addition to find out what are the benefits and challenges, was to find out do people really notice if heat demand response is in use. Next slide, please. The temperature control of these thermostats was changed ±1 degree from the normal setting value, in this way uploading and unloading the building in energy. So for instance, the first step upwards here is kind of storing heat into the building. Next slide, please. The residential building pilot was built in a building with 167 apartments, and although there are benefits with this kind of technology, how you can schedule and control the temperature in the building in a new and a clever way, and then you can get feedback on your energy consumption. There are some challenges we faced. We used the apartment's own Wi-Fi networks in this pilot, and that proved to be challenging. So it's better to have a more central Wi-Fi network in the house when you want to implement this kind of things. And then also customer engagement is one challenge we faced in this case. So what we can say that a more central kind of control management for apartment buildings would be more beneficial than the smart thermostats, although they have several other benefits when we think about heat demand response. Next slide, please. Then the office building pilot, in the residential building pilot, and also in this office building pilot, the tenants or office personnel, the heating quality perception was measured, and on both of these pilots, the people didn't notice in their comfort level if the heat demand response was in use or not. The office building seems to be more suitable for heat demand response with a room level control using smart thermostats. And of course, in the office building, they have a more known usage schedule, and they are, for that reason, they are more suitable for heat demand response usage. Next slide, please. And if I want to pick one result from this studies, it was that we wanted to know if people notice in their comfort level if heat demand response is used, and there was no correlation with the heat demand response management controls and how people felt that, which was a kind of a key result if this kind of service can be taken into use. Thank you.
Thank you very much, Hannu. Exciting potential. Now, let's move to another optimized solution, which is public lighting, which could reduce the energy consumption of many or a lot of different cities. Monsieur Louis-Frédéric Robin, you are most welcome to start with your presentation.
Thank you, Mathieu. Good morning, everybody. My name is Louis-Frédéric Robin, so I'm the Group Director for ENGIE, a company for cities and public infrastructures, and leading the public lighting and safety solutions offers. So ENGIE, as mentioned by Mathieu, is a worldwide company, energy company. We operate in lots of geographies in the group, and public lighting is one of our key expertise. I would like to take the opportunity of this webinar within the SMARTLife initiative to give you a feedback on a project based in Nantes, in the west of France, about smart lighting. You can move to the next slide, please. Thank you. Great. So this project has been implemented in Nantes, in the west of France, on a new area of the city where we expect that pedestrians and citizens will discover this former industrial part of Nantes. 80 smart lighting points have been deployed there, on which 50 luminaires and lamps have been replaced by LEDs. Smart lighting is meaning that you are shifting from traditional lights, traditional luminaires, from using incandescent lamps to LED technology. LED is now mainstream all over the world, and you can expect very huge saving. We will come to that afterwards. And you shift from traditional lamps to LEDs, and then you integrate within the luminaires or close to the luminaires an intelligent and a smart drivers and connectors, which allows you to manage remotely your luminaires and be able to create dimming scenarios, meaning that you can rise from 0% to 100%. In this specific case, we are dimming from 30% to 100% of the full light potential. And we combine those smart luminaires with motion detectors. Motion detectors meaning that we try to adapt the lighting level on the real presence of citizens. This is really the purpose of smart lighting. So we operate now since September 2018 in Nantes with these solutions, and this is the FlashNet IntelliLight solutions that have been implemented in the luminaires. So you have the hardware implemented in the solutions, and you also have a software, what we call the CMS, the component management system, that allows you to manage on your device, your computer, your phone, wherever you want, the solution. So clearly the outcomes are very promising. So for the time being, the energy saving for the first year is 75%. The target was 78% in terms of CO2 reductions and energy reduction. So we are really on track. And we can now count how many GHG emissions have been reduced. So you see that on this graph, on this chart, you see that LED effect can give you minus 60% of energy reductions. In the reality, we can come from 50 to 80%, depending on when you start. If you are very old traditional bulbs, the LED effect will be very more aggressive. And the dimming capabilities will allow you to get from 10 to 30% more in terms of savings. But in this case, we gain 75%. On top of these outcomes, which is very effective, I would say, and very robust, you can get more additional savings. You can have also on the supervisions of energy, you can also adjust your energy subscriptions. It is quite common that in all the geographies, we make LEDs replacement, but we don't adjust also energy subscription. So there is some savings that remaining in this part. So the benefits are for, of course, users and inhabitants, definitely. For the technical services of Nantes, they can switch on off the luminaires remotely. They can dim the lighting level, and they can also have maintenance savings, because from traditional patrolling people on the ground, now you can just manage, or you can limit the management of your lighting system remotely. Also, we are able now to make preventive, curative, or predictive maintenance on the luminaires remotely. So this is quite huge savings. We expect roughly 30% of savings for maintenance. For users, for citizens, which is very important, they can benefit a more pleasant travel, a pleasant journey within this new area. Definitely, when they are on the pavement, the lighting level is adapted to what they need, what are the standards expect from the lighting pavement. And when they are out of the pavement, out of the streets, the lighting level is dimming as much as we can in order to reduce the light pollutions and the noise pollutions. We can also now in lighting, we want also to make the quality of night coming back in our cities. You have all of you, when you take a plane, when you are surrounding at night in your cars, you see this lighting allow all over the municipalities, which has an effect on biodiversity, and within the biodiversity, humans are part of it. So a way to respect nature, to respect biodiversity, is to offer night quality and just light when you need. This is very important. Of course, there is a faster maintenance interventions, because when there is a failure, we know immediately where and why. There will be, of course, an economic benefit for the municipality in terms of energy savings and maintenance savings. So it could be quite huge. As already mentioned, this low energy consumption will have a direct impact on the CO2 bills of Nantes. So very effective. If you can move to the next slide, please. Thank you. So if we imagine making this solution at scale for Nantes, so Nantes is 95,000 lighting points, which is quite huge. If we implement these solutions on all lighting points, we can imagine that the city of Nantes will switch from 37 gigawatt hour to 9 gigawatt hour. So yeah, it's very impressive how it's effective, leading to their energy cost shifting to 5 million euro to roughly 1.4. Inflation is not taken in this simulation, but that means that we can expect that they will divide it by more than 2 their electric costs. And there will be also minus 30% in maintenance costs for all the lighting points. Of course, there is another benefit from smart lighting. Yeah, it allows you to make these infrastructures in capabilities to support your smart city project. This is really an infrastructure that could play this backbone for smart city in the coming years. Lighting infrastructures is surrounding all the pavement, all your streets, so the adherence with territory is very, very high, and connectivity and power will be also available for all IoT you want to deploy on your city. So really, you will have one other effect. You make savings, and at the same time, you set up your infrastructure to jump in the future of the smart city. You see on the figures on the left part of the slide that new features, which is the count for today is quite zero. It's 25 million at European level, but we can expect in the decades to come, there will be a CAGR over 40% per year, and we can expect roughly 670-200 million euros of revenues, of investment related to smart lighting, on which connectivity represents 90% today. This is really what we forecast. So let's see. If we go now from Nantes, we imagine that we go at scale for Nantes, how it will impact Europe if we go at scale on the European market. So the European market is roughly 74 million lighting points today, expected to be at 80 million lighting points by 2028. You see that the implementation of LED have a CAGR, very positive CAGR, 2-digit, roughly 10% of CAGR per year for LEDs implementations, and smart lighting is less, but we can imagine that by 2028, 1/4 of the lighting points will be smart. If in Europe lighting is using roughly 1.6 million kilometers of roads in the EU 28, you see that from 35 terawatt-hours of electric consumptions, which actually represents 1.3% of the total electric consumptions of Europe, representing 4 billion euros per year, we can imagine to generate 26 terawatt-hours of energy savings. Just improving the way we consume the electricity for lighting, and at the same time improve the lighting quality. That means that this implementation will have only positive impact on lighting. So in my opinion, this is really important that we use SMARTLife webinar and our networks to share that smart lighting now is a robust solution. It's available on the market, and it would become mainstream, that there is no doubt that every municipality now has to shift to these solutions. So this is what I would like to share with you today. So I would like to thank you.
Thank you very much, Louis-Frédéric. Thank you for this clear invitation to all municipalities, local authorities and regional authorities, and to look at this solution, this public lighting, smart public lighting, in order to become smarter, or in order to for the companies to make or work on how to bring their city to become smarter. Thank you very much. Now it is time to come back to the citizen and show how to engage them in the energy transition, taking the example of the electric power tenant supply implemented in the city of Hamburg. Doris, it is your turn to spread the word.
Okay. So I hope I can. Oh, no. So I wanted to try to share my.
You are sharing at the moment, so no problem.
I'm sharing. Do you see my?
Yes, we do. We do
okay.
see it.
Okay. Yes. I want to tell you something about electricity tenant power concepts, and how the citizen can share at the race production. It's a short agenda. I want to show you and want to give you an overview of the concept, show you the elements of electricity direct power projects, the roof, the main players and the framework. And then I give you a short summary with the opportunities of this concept. And please, next slide. Yes, I can say just do it. It's a very good way because it's PV, photovoltaic is a very proven technology. It's okay and it's long checked and running. And you are using existing roofs and you don't need additional space like for windmills. You have short cable runs if you use the direct power, no transport loss, and the population is participating in the race production. The people living in the houses and using the houses can take direct electricity from their own roof. And the users, the consumers, have a long-term security of the energy costs. But it's a very complex way. You have to start with the search for a suitable roof. You have a very long-term capital investment, complicated contracts, and long-term contractual commitment. It's over 20 years. And there are numerous of ordinances and regulations and repeatedly reformed and somewhat changed legal situations in Germany. And so for this part, I only can speak for Germany because I don't know the legal situation in the other countries of the EU. The next slide, please. This is an overview. We made it in 3 models. One is the 1-to-X. There is a residential building and many people living in the residential building. And they are using the, they are using, they are tenants and they are, you have to make a contract with the owner of the building to use the roof. And then you have the electricity power delivery contracts with the tenants. And so it's a 1-to-X, but it's a very direct concept. And if you have a battery storage, you can use most of the power in the building. The next way is 1-to-1. We made this at an organic bakery in attention with mySMARTLife. It's one building, the bakery building with the roof. It's a new building. And we, as Energienetz Hamburg, installed the PV plant on the roof and are supplying the power to the baker. And then we have some projects with a combination. There is that are office buildings where many offices are in, and some tenants of the offices, some users, and then we have it's nearly like the first part with tenant in the residential building. And you see it, we put the PV plant on the roof, make the directly supply contracts with the consumers, and the roof using contract with the owner of the building. Next slide, please. Yes, the start, the roof. There are some pictures, and in Hamburg we have the advantage that there's a solar atlas, and it shows in green color the suitable roofs. So you can click it on it and see an overview over Hamburg and can see which roof could be suitable, and then go in contact with the owners of the building. And on the right pictures, you see above the roof of Kampweg, there is a PV plant of Energienetz Hamburg installed in mySMARTLife. And other roofs we were looking for were too old. The roof has to stay 20 years with the PV plant. And so it's not good to take an old roof, and it's not suitable. And another roof of a residential building has this destructions with lights on the and chimneys and so on, and you can't use it. You can't install a good PV plant on it. Next, please. So I made a stakeholder analysis, and these are the main players with PV plants and tenant power direct supply. And the house owners are the most difficult partners because they had the smallest advantage, and if they are not using rooms in these houses, you can't pay a big rent for the roof, and so they have no advantage and no compensation for the roof. The contract is very long, and it goes with a restriction of the roof conversions, and the house owners can also be in a hybrid situation. They can be a roof giver and also electricity customer with the direct concept, like at the bakery. Then it's another situation, because they get green electricity from their own roof for a very good price. The next players are the tenants or the users. The tenants are often the initiators. They come to us and get in contact with us and say, hey, we are living there, and we would find it a very good idea to take the electricity from our own roof. And they are very interested in this concept. And so they are often the proponents and supposers. And yes, they can help you if you want to make such concepts. Then Energienetz Hamburg AG is a cooperative, citizen energy cooperative. And they want to promote the energy turnaround, the energy change in the Hamburg metropolitan region. And our task is the planning, the financing, construction management, operation of the plant, and the electricity supply of the consumers. And we use the capital, the finance of our members of the cooperative. And then we have the solar electricians. They are the installers. We don't install it for ourselves. And they're doing the technical planning and the delivery of the components and install it. And we also have grid operators, grid connection, and purchase of the surplus energy, and the billing and payment for the feed-in tariffs. This is around, but not so important. but it all takes time and resources to get them into the boat. Next slide, please.
We need to go a little bit faster, Doris.
Okay, yes. Now the framework. We have the legal framework. It's very complicated in Germany, and I don't tell more about this. The environmental framework, it's very good. We have no emissions during plant and operation and no danger to animals in installation or operation. The disadvantage is that the production of the components are most in Far East, most in China. And economical framework, we have a high investment, about 900 euro per kilowatt peak. And I show you the payback periods. It needs 15 to 16 years for the payback of the investment. So we can go to the next slide. And the next slide are only the steps, and I can tell you we have to define the standard, and then we can start and plan and acquire the roofs. And yes, I can give you this if you are very interested, and it's in the exploitation roadmap. Yes, these are our steps to make this business. And then I'm on the end. And don't hesitate to get in contact with me. Okay.
Thank you very much, Doris. After this inspiring idea on process, I would like to remind the audience to write down the questions that you might have in the chat box, because we are coming to the last presenter. And so now let's look how to make an urban platform more flexible and open to different sources of data with the Open Urban platform developed by T-Systems or T-Labs with the Lighthouse City of Nantes. Ingo, please show us how to get an open urban platform to enable more smartness and efficiency in the city.
Sure, thank you. Just let me share. Hope you can see my slides.
Yes, we can. If you can also share your camera, it would be nicer for the
No, better not, because I have really hard network issues here. So I hope the connection holds on until the end of this presentation. So yeah, what we also developed in the mySMARTLife project was a so-called open urban platform. Basically, that's an umbrella name, because under the surface there are in fact two platforms. One part is from Hamburg and one is from T-Labs. So T-Labs is a part of Deutsche Telekom. So in this presentation, I want to introduce you to both of it, but let's start with the DT part. So this is we implemented a platform as a kind of bridge across different infrastructures. So what you can see here on this slide is a bridge, or something that is across different backend systems. You can see here different street lighting systems, like from Schroeder, Zumtobel, Fleischnet, and also some environmental backends like this breeze sensors. So this is just to give you an impression what this platform is about. And since we are here, since we do not want to get too much technical, you can imagine this also as a bridge across different players, across different companies, across different in an ecosystem, across different players in an ecosystem. And yeah, what we have done is, yeah, we use the standard. So on northbound, someone can implement third parties, small startups, or even companies owned by the city, or also private ones can. They are able to implement use cases and scenarios across using all these different players, using data from all these different players. Just to give you one example, is the adaptive lighting, so that this is from the environmental sensor. You get different, whether it's raining or not, and then you can switch the street lights in different parts of the city. On the next slide, you can see that is the in fact the base of, or the that's the overall platform. So one part is implemented by the city of Hamburg, and they used in fact an OGC standard, so it Sensor Things API, but there's just as a remark, but it's an important remark. So, and we used another standard that's 1M2M, and in this project we connected both. So we are able to connect both of these worlds, and so applications that usually just talk to our system, they can also use sensor data from the Hamburg system and vice versa. And this is a very important, because today you will not have this one own single standard in the smart city. You will have many of them, and we demonstrated here how to connect both of these platforms. So for what, we also did a kind of we did a market research. And there are several verticals where you can use this kind of platforms. So one is for mobility, where we implemented, for example, applications like, you can see where the next free EV charging station is. We connected various parking systems. We also demonstrated together with the HAW, the University of Hamburg. We demonstrated some energy use cases, and also some infrastructural things. So these are the main topics where we see the market goes through, and where such kind of platform is usable. And nevertheless, this kind of platform is, we can see it as a kind of core, but it is an important part, but it's just a part. So for in order to build up a whole ecosystem in a city, you need, of course, different layers or different systems. On the very bottom, you have different devices or infrastructures that are connected to an infrastructure backend. Because for example, every street lamp, they have their own. Mostly they have the manufacturers have their own software and their own, system. And all the system you can connect via this open urban platform. And on top of it, you can create either directly applications, or you put some intelligence in between that does some magic with the data, some intelligent, smart algorithms or AI algorithms. So what I want to say, that this open urban platform is a very important part of a smart city stack, but it's just a part of it. Yeah, and this concludes my presentation, and so I think we have now enough time for some Q&A. Thank you very much.
Thank you very much, Ingo. Yes, the question and answer session is now open. So I haven't seen questions yet, so I will start with a very short one for Doris, since she will have to leave very soon. Could your solution and processes implemented in Hamburg be used in other cities in Germany or in the world? And would Energienetz Hamburg be ready to support other partners to follow your steps? considering that they have to be aware of the legislation of the country related to PV panel and the share of energy on the grid?
In Germany we can help, and it's possible to do it in whole Europe. It's no problem. It's a way for each city and small city, and because you are independent from other infrastructure, and so you can principally use it in everywhere. But in Germany, there are especially legal frameworks, and this is very complicated. And this is another in each country in Europe. So we can help with the technical and planning, but we can't help with the legal questions out of Germany. And I must say, we are a very small company and we don't have so big resources. We can give you a little help and ask you some questions and can tell you how to get the next step. But we have not the resource to go with you each step.
Thank you very much, Doris. Now, I have a question. Was the Hamburg Open Urban platform made using open source code? Oh, I think it's a very relevant question for you, Ingo, if you can take this.
Yeah, and in fact, the Hamburg part was made by open source code. So, and it's basically the what is it? It's a so-called Frost server. It's you can download it from Fraunhofer, and the 1 and 2M part is not open source. We used an open standard, so you can implement it. You download the standard and implement the core server, but it's not open source.
Thank you, Ingo. But I think you are also working on some other integrated standards.
Yeah, we connected Sensor Syncs API and 1M2M, and now we are also going to connect FireWare and 1M2M. So we developed this kind of connection too.
Thank you very much, Ingo. I will move on with a question for Hannu. For what type of city heating environment would this type of heat demand response arrangement suit best?
Okay, so Helsinki has quite many thermal storages already, so this type of arrangement is another option, but not kind of a totally critical. So for environments where there is no heat storages or that type of capacity available, so for that type of networks and environment, this could be useful. And of course, there is a difference between are you doing retrofitting or are you building new houses. So when building new areas, this could be one option to take into account. And of course, there's an other aspect as well. This is one way of getting to the direction where customers can be part of a bigger energy system. So in that sense, how they could participate in the heat production, and that's an important step.
Thank you very much, Hannu. So a very last question for Louis-Frédéric. These are impressive energy reduction percentages, what you showed us. But considering the number of cities and their characteristic, each city district has its special needs or expectations, how can you make sure that you have the right solution for the right need? We can't hear you, Louis FOURDEG.
Sorry, I wasn't good.
Perfect.
Thank you for these questions. The idea is that once we decide to implement smart lighting, you immediately benefit the capabilities to size the dimming demand on what is really needed based on what your specificity. So if we imagine that, I don't know, in your city you can't dim the lighting level because there is always someone in the road, we can say that we will reach only 100% of lighting level, and we will stay that way. So I think the idea is you need to shift from, of course, traditional lighting to LEDs because you will benefit immediate savings from with this new technology, which is very mainstream today. Most of the facility now are stopping their traditional incandescent bulbs manufacturing to LEDs. And then if the hardware and the software is there, you can size exactly on what you need, really. So this solution is very customizable, I would say.
Yes, and also the different type of lamp post, because you can add different type of options, whether it is with.
No. You can manage the lamp post is the pole plus the luminaires, meaning that you can respect the poles and the historical poles you have in your municipalities and find the good luminaires, including you can maintain the shape of the luminaires if you want to keep an historical luminaires in the centers of your cities, and also refurbish your luminaires and make it LEDs luminaires or smart luminaires, even if it's an historical one. So there is no problem to do that.
Perfect. So thank you very much. I think that without more question, before closing this web seminar, a last advice from my side: save the date of the last Thursdays of the months of April, May, and June 2021 from 2 to 3 CET, which means the 29th of April, the 27th of May, and the 24th of June 2021, and join our next dissemination web seminars, respectively presenting mobility solutions, energy solutions, and ICT solutions in the project of mySMARTLife, but also in the other Smart Cities and Communities EU projects of Matchup, Making City, Stardust, and Positive. These series of web seminars are conceived to open a communication channel where market actors have the chance to interact with the innovative organizations active in the project mySMARTLife and the other project that we just mentioned before. To conclude, we just want to thank the speakers and the organizers of this web seminar for their engagement and excellent work, but also the audience for your interest and your attentions. We hope to meet you again on April the 29th. Take care. Bye-bye.
Bye.
Bye-bye.